Hi again. We're going to discuss in this video the concept of a methyl shift and how it can satisfy a rearrangement for a carbocation. We saw in a previous video the idea of a hydride shift, where the thing that's moving is a hydrogen taking its electrons with us, and so we would draw the arrow like that, satisfying our carbocation. In this case, what we're going to see is a methyl group doing the same thing. And so we're always talking about a neighboring hydrogen or methyl group. It's only one step away from the carbocation. It can't be too far apart for logistics of moving things from place to place. And we don't have shifts occurring of anything larger than a methyl group. So we're only talking about small pieces of the molecule being able to shift. This all goes through the idea of a carbocation intermediate, but when we try to illustrate a methyl shift, we need a slightly more complicated molecule. So let's imagine a molecule now that looks like this, but has some significant branching on one end. And again, we'll examine a reaction with HX. First step of our mechanism is exactly what we've seen before. The nucleophilic pi bond attacking the positively polarized part of that binary reagent to give us now our more stable carbocation intermediate. This follows Markovnikov's rule just like we've seen before. However, if we notice that one step away from that carbocation, which is right now a secondary carbocation, we have a methyl group. And so we can illustrate a methyl shift like this, which will show us now our backbone, still one methyl group there. Now we've moved another methyl group here, and I'll illustrate that explicitly to show where that methyl group is. And we've generated now a tertiary carbocation, which is more stable than the secondary. This would be considered the intermediate or transition state in the reaction. And as before, the reaction will resolve now as the earlier liberated negative part of that molecule attacks the electrophilic carbocation step to generate now our substituted molecule. Let's clean that up a little bit for you. And again, this would be the major product. The minor product would be one that we would expect without rearrangement occurring. So essentially coming from here with no rearrangement. With all of these carbocation rearrangement steps, we would expect to get two products. Again, it's hard to quantitate without actually doing the experiment which one will be at which percentage, but we can predict that the product that comes from the more stable carbocation intermediate will be the major product, and if present at all, the product originating from the less stable carbocation intermediate will be the minor product.